This video reviews finding the coordinates of stationary points of a function. Now, if we differentiate this function, we get dy by dx equals, we times by the power and subtract 1 from the power. So this becomes 3x squared, take away 2 times 12 is 24, x, and 48x just becomes 48. So that's dy by dx. Now the stationary points are where that equals 0, where there's no gradient. So to find the coordinates, I need to solve the equation 3x squared, take 24x plus 48 equals 0. In other words, where is there no gradient? Now I can divide this equation by 3. So I get x squared, take away 8x plus 16 equals 0. This then factorizes. So x minus 4, x minus 4 equals 0 because minus 4 take 4 is minus 8, minus 4 times minus 4 is plus 16. So it's factorized, I've got a repeated root, so the only turning point is at x equals 4. It's a turning point or stationary point. So x equals 4, that's almost a coordinate, but to find the actual coordinate I put x equal to 4 into the y equation. So the y equation gives me the y coordinate, and if I let x equal 4, I get y equals 65. So the coordinate is 4, 65. Now this could either be a max or a min, or possibly some point of inflection. And to discover what this coordinate is, I can do the following. Now, as a rule, it's often worth trying out what's called the second differential test first. Now, if I differentiate this again, I get d squared y by dx squared equals, so times by the power, so 6, and take 1 from the power, so 6x, take away 24. And if I let x equal 4 in this, I get 6 times 4, take away 24, this equals 0. Now this test works in the following way. If the answer is bigger than 0, it's a min point. If the answer is less than 0, it's a max point. But if the answer equals 0, then it could be any of these three configurations. So when it equals 0, we have to revert to what's called the first differential test. And for this, I do a little table. So I know the turning point is at x equals 4, so I put 4 here. And I look at a value either side of 4, so e.g. 3 and 5. And I find the gradient, i.e. I use dy by dx, either side of 4. Now 4 is a turning point, so the answer for the gradient must be 0 by definition. And if I put 3 and 5 into dy by dx, the gradient, I get the following two numbers. When x is 3, dy by dx equals 3. And when x is 5, also, if I put it in, I also get by chance 3. Now this is the gradient. So this means there's a positive gradient. It then levels off and becomes 0 when x is 4. Then afterwards it's another positive gradient. So therefore positive 0 positive. This is what's called a point of inflection. So I've therefore classified the turning point when x equals 4 as a point of inflection.